G'day guys, Mr. Bennett here. Today we're going to be looking at an example where we're going from above the ground to the ground. So in this case we're going to be launching an arrow off a cliff at 40 metres per second at an angle of 20 degrees. So if we want to look at what that will actually look like when we're doing that, then it's going to be something like this. It's going to be launched up there, it's going to go to a height, and it's going to go there. Right, so what do we know? We know this over here is 12 metres. We know this angle that's being launched at over here is 20 degrees. Alright, so in terms of idea of doing this is to show you that everything else is essentially the same, only just a couple of little minor differences. So the first thing that we need to do is we need to find the vertical and horizontal components. So VV is going to be 40 sine 20. So go to our calculator, so 40 sine 20 gives me an answer of 13.68, and we might as well do that one here as well. So 40 cosine 20 equals 37.59. Right, so we can write those two down if we go back to our Word document. So that there is going to be 13.68. Now, even if it doesn't ask you to do this, you're going to need to actually do this. So it's essential that we know these two values if we're going to work out the range or the time of flight. We certainly need that, and that was 37.59 meters per second. Alright, so you get a couple of easy marks for doing very basic tree calculation. Right, the next thing that we have to do is the time of flight. Now, from where it starts, which is up here, to where it goes down there, we know that our SV is going to be minus 12 metres. Right? And that's going to be then equal to the initial vertical velocity, 13.68, times by t, take away 4.9 t squared. We rearrange that equation, minus 4.9 t squared plus 13.68 t. Now when we bring that across, that's going to become plus 12 equals 0. Now you can either graph that, as I said before, and you get a quadratic, or you can go into your polysim. So let's go into polysim, and we can solve that using our calculator. Right, so the root finder over here, so number one that we want to do, and that should all be set up from last time. Even our A is still the right value. Now our velocity was 13.68, and then our time, now remember it was minus and it now became plus, so it's actually 12 meters that we're launching from, and then all we have to do is press solve. And we get a minus value because remember it's launching from a height, so we're going back that way. So 3.49 is the time that we're looking at here. Okay, so we go back to our document. So t equals 3.49 seconds is what we're looking at there. Remember to put units on, and generally underline your answer, makes it life a little bit easy for you. Now to work out your horizontal or your range, so SH is going to be VH times by T, so VH is actually 37.59. Our time of flight is going to be 3.49. So therefore I can do that calculation. Now remember I have to quit out of here. Clear screen. So therefore it's going to be 37.59 times by, what was that time again? 3.49. Okay, so 3.49, and we get an answer 131.19 equals 131.19 meters. Okay, so it's going a fair way, so you get a bit of an idea if you could actually reach a target when you're doing that. Now we could also work out the velocity on impact if we wanted to. Now it doesn't have to be that, we could do it any time here, but let's do that for when it's hitting the ground. Now remembering it's going from above the ground to below the ground, we're expecting it to pick up some extra velocity. So it should be going faster than 40 meters a second. Now, so the first thing you have to do is work out the vertical component of velocity. So that's equal to our V0 plus our AVT. So our initial vertical velocity was in fact 13.68. That's going to be minus 9.8 times by the time, which is 3.49. So I do that calculation, that will give me my velocity. So 13.68 take 9.8 times 3.49, and that will give me a speed of minus 20.52. Okay, so minus 20.52. So then, obviously, to work out our velocity, we need to work out this thing over here. So it's going to be simply our horizontal velocity, which doesn't change, and that's going to be 37.59 squared. And then add, now it doesn't matter if it's minus or positive, because you're going to square it. And so therefore that's going to give us our thing over here. Right, so again, do it in one step. So 20.52 squared plus 37.59 squared. Again, we're looking at an answer that's going to be both bigger than both of those. So that's going to be 42.83. That's equal to 42.83. Now, if it is velocity, I forgot to do this in the last video, but we need to also find the angle. So the theta is going to be equal to inverse tan of the vertical velocity, so that's going to be 20.52 all over the horizontal velocity is 0.59. Alright, so go to our calculator, do that calculation. So inverse tan of 20.52 divided by 37.59, and that gives an angle of 28.6. So therefore that's equal to 28.6 degrees. So therefore velocity is 42.83 meters per second at 28.6 degrees below horizontal. Now again, I forgot to put my units in there. Must do that, otherwise that shows a lack of understanding of physics. Alright, there we go. Alright, the last thing that we need to do is find the height that the projectile is going to go to. Again, we're going to use the concept of that gets to a certain height. We know the vertical velocity there is 0. So again, we're going to use our formula here to do that. So 0 is equal to initial vertical velocity, which is 13.68. Take 9.8 times t. So therefore t is equal to 13.68, which will be minus, divided by minus 9.8. And so we can work that out. 13.68 divided by 9.8, and that's equal to 1.4. We must round that off. 1.4 seconds. So again, if I want to work out how high my arrow is going to go, remember it's been launched off a cliff which is 12 meters high. I put all this information that will actually find it for me. So initial vertical velocity 13.68 times by a t, which is 1.4. Take 4.9 times by 1.4 squared. Again, go to your calculator, do that. So we got 13.68 times 1.4, take 4.9 times 1.4 squared. Okay, that's 9.55. So that's equal to 9.55 meters. Alright, so therefore maximum height is going to be equal to the initial height it's launching off the ground, which is 12 plus 9.55, which is equal to 21.55 meters. Remember, it's been launched from 12 meters, so it's going to go another 9.55 meters above that. So there again is another question that goes through the whole process of finding a projectile's conditions. Alright, so good luck with these questions. Make sure you identify those. Really, I mean, you don't have to identify it, because the only real difference with these questions is this bit here, where you actually have to work out your time of flight. So the only thing that's really changing here is this value. Okay, whether you make it a minus, whether you make it a positive, or whether you make it 0, and that will just affect your time of flight. Anyway, keep going with these questions in page 219 onwards, and use these examples to help.